chat window, and so you can also use that. Uh, uh, that's a free website. Let me see whether I can find that. So I'm going to put that in chat window, so you can also uh, hold on. That's just not. Okay, anyone see the link I type into the chat window? Okay, can you click on the chat window and see what you see? Do I have someone is brave enough want to share its window? Can I have a volunteer? Oh, I'm going to who is how do we decide who is a lucky person? So, uh, let me see. I'm going to pick someone whose name start with A. Whose first name start with A? Uh, is that Aiden?
Sure, I'm fine sharing my screen.
Sure, sure. Let me see. Yeah. Can you try to share your screen?
It doesn't allow me while it says you're sharing your screen. Um,
I should enable you now. Can you try again? Uh, I enabled you.
um, it's still telling me.
Still,
Yeah,
uh,
it's coming up. You cannot share. You cannot start share screen. Okay, host. Let's say now.
can you try again? Hold on, let me see.
So, I think it's gonna stop your screen sharing, but yeah, I'll start sharing my screen.
Yeah. So, uh,
It's fun. Are you guys able to see?
not yet. It's still
Oh,
showing. Okay, now we see. Okay, very good.
fun.
So see when we see on Aiden's screen, you see features, and then there's the middle layer, and then there's the output layer. And it actually says how many neurons we can put. So there's a plus minus, and you can increase and remove some of the neurons there. And then, in fact, there you can also increase or decrease the hidden layers. You can also you can even increase or decrease the input features. The features. So what the goal is, you see, there's a two. Let me see whether I can annotate your. Can I annotate?
I have the ability to, but
Yeah. Let me see whether I can have an annotate. No, I don't see the annotated button there. Sorry. Okay. So what the idea is, you see there are blue and orange dots on the image. The idea is trying to develop a neural network model to classify the blue and the orange dots. So can you click on the train? There's a play button on your top left. Yeah, click that one. Yeah. Very good. See there, and you can stop. Click stop there. So you can actually see on the top right the curve going down. That's the what they call the training loss. So when that the loss means the error between the expectation, what's predict and what's real. So in this case, the blue they are all in the blue region. Orange they are all in orange region. So this is almost like 100% accurate. Very simple, very this is actually just one layer of neural network. But you can actually try a little bit, try to decrease the number of neurons. If you decrease the number of neurons into two, and then train it again, see how it works. Okay, you can't stop. Yeah, it won't change very much. So in this case, you can see it's actually the loss, if you remember, the 0.17, the previous one actually is much lower. There is also can you scroll down, see what the accuracy at the bottom? No, it didn't show. Okay, but you can estimate clearly there are some orange in the blue region. So you see the on the so there are orange dots in the blue region. So that's the error. And there are also blue dots in the orange region. In the middle, you see a few blue dots in the orange region too. All kind of borderline, especially on top, there is one blue dot clearly in the orange region. Yeah. So there are some misclassification there. So by so you can see if we increase the number of neurons in the hidden layer, it's going to improve the accuracy. You can actually try there are actually many other things you can try. There's a learning rate on the top. You see something learning rate, basically how fast the neural network learn each step. And then there's also so-called activation function. That basically means from each layer to the next layer, how the message or signal will pass from one layer to the next. And there's also another something called regularization. That's actually it's a fancy it's a technique to avoid the neural network from overfitting, from basically making mistakes. Yeah. So and there's a regularization and regularization rate, but that's kind of a bit advanced. Let's just skip over. And then if you at the very right, you see there's a classification and regression. Classification basically means we put things into labels. 1, 2, 3, 4, 5 different labels. Red and in this case, red, orange, and blue. That's called classification. Regression means we have to estimate a value. For example, what's the chance we'll have a rain tomorrow? If it's a classification, it will be yes or no, or maybe there's the one in the middle said maybe, three labels. So will it rain tomorrow? Yes, no, maybe. That's called classification. But will it rain tomorrow? If my answer is say 90% chance of rain, that's a regression. That's a number. I put it there. So that's a regression model. If it's a classification, I would just say no, it won't rain. Yes, it will rain, or maybe. But if it's a regression, I will give actually a number there. So 90% chance will rain tomorrow. That's a regression issue. So there. So if and you can just spend time trying to play with this, and then we can see. In fact, Aiden is there trying. So okay, so Aiden, can you go scroll to the top right, pick a different category. So on those numbers, can you pick go back to the data? See, there's a place called data. See,
Yeah.
yeah. Can you pick other things?
Spiral.
Yeah, pick a spiral and then try again. Try training again. Yeah. So the spiral shape is more complicated than the previous one. The previous one is actually is easier to partition because we have blue in the middle and orange on the side. But the spiral shape, the blue and orange is kind of intermingled. So here we can see the neural network is not performing very well. Okay, so how do we think we can improve this neural network to perform better for this spiral shape? And you can put your suggestion in the chat window. So and then we can help Aiden to make some change here to improve the performance of the neural network. what is the suggestion we have? Can someone put in the chat? Oh, something already. Choose what? More hidden layer. Choose time one time. What does that mean? Time one, time two. Use. Uh, okay, let's try more hidden layer. How about that? Instead of add, yeah, add one more. Okay, yeah, let's see how that works. Yeah. Can you just click train? Uh, uh, okay, it didn't help this time. Okay, let's try what else? In the features, we already tried x1, x2, right? Try x square. How about pick x square, x1 square, x2? Yeah, did that help? Yeah. Can you? It's not very helping. Okay. How about pick x2 square as well? Uh, it seems to help a little bit, isn't it? Yeah, actually, what this means, carefully choose appropriate data is very important to train neural network. And in fact, that's if you see some of the critique about the AI work, is it take a lot of people to curate a good data to train neural network. Now, this is good example. We didn't change anything in the middle of the neural network, but when we just change the input data, it affect the performance of the neural network. So, okay, this is clearly can be, but still not good enough. Can we train the neural network? What other approach we? Okay, see. What is sign? Or sign? What is that? Uh, how about increase the number of neurons in the middle? Yeah. Let's
Seemed like
include.
this blue area over
Mhm.
here was kind of decreasing closer to zero from the simulation.
Yeah. How about add four neurons? Uh, Also the first layer also add four because the way neural network work, the information had to pass from one layer to another. So if we want to increase more layer later, the information actually comes from the previous layer. So if we want to have more information, we need to let that information go from the beginning to the end of it. Uh, okay, let's try this again. Okay, now it's working. Okay, this is much better, but we can actually even change it to make it almost work 100% correct. This is still you see they are orange in the blue. Uh, okay, what are other method we can do? Okay, and then you don't have to wait. You can just try.
Oh, oh no, it's on me. Oh, fun. Okay.
Yeah. You can and other student can also try on your own and see, and if you find out, you can just share
Maybe,
your screen as well. So
maybe at the let me try adding one neuron at the end, just see what happens.
sure, yeah, you can try that. Yeah.
Oh, well, that's good actually. So
Once the curve become a bit flat, it's not going to improve much anymore. So this,
we want our training loss to be lower, right? Like
yeah, but
close to zero.
once that curve is almost flattened, it won't change too much anymore.
Oh, okay.
So this is it. Yeah. So in a way, you can think about how a neural network works. Is really a matter how we design the neural network. Right. So if the neural network is not designed properly, we can run it for a long time, training a long time, it still doesn't improve the performance. So how to design a neural network properly is actually a very important first step. So anyone else figure out how to do this, achieve a 100% accuracy? Oh, this is close. Uh, this is okay, close, but not 100%. You add another layer. Okay.
Yeah, let me try this. So this isn't looking good.
Someone actually want to put the last layer into one neuron. I doubt that would work, but you can try. Someone says put the last layer into one neuron, test loss and training loss are both within point 0.1. Uh, point 0.1 is actually very high though. Uh, I doubt that will work. Uh, if this is basically because if you want to tell something two-dimensional, you have just one neuron means one number output. You have just one number to tell a two-dimensional feature. That probably is not enough. So like if we want to go on a map, we have just one number to say where to go. That would be really hard to tell. So uh, okay,
Should we keep the learning rate the same? Should we mess up anything at the top?
that's okay. That's actually those learning rate is those will be fine-tuned. Those are the optimization. In this case, we're actually still working on the so-called architecture of the neural network. And those are the so-called hyperparameters. Those actually in the fine-tune or optimization stage. Okay, how about you add more neurons into the first layer? Add two more neurons. Yeah, let's try that.
It's looking better.
Yeah, it's looking better, but still, they are a streak of a blue in the orange. So okay. And how about add a few more input features? X1, X2, and also what's that? Sine and sine X1 and sine X2, I guess. Yeah. Oh, I see. That's what someone says sign. So, okay. Uh, huh. This is strange. Okay. And how about you reduce the last layer to two neurons? I wonder. Okay, this is still not why. I tried this. So let me see what I do is different from yours. I pick all input 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Six middle layer. Oh, I can. How about we add another hidden layer? Yeah. Okay, let's try that. Yeah. See. Okay, so this oh, this is almost, it's just two blue dot in the orange. It's close enough. Yeah. So, uh, if you maybe you can also try put more neurons in the middle, in the first and second layer. Put let's put two more neurons there. So, now some actually say that change the batch size.
Should I try changing that?
Uh, this uh, someone said let it run a while and then it will found it. I guess we didn't wait long enough, maybe. So yeah, you can see the loss is already very, very small now. Point zero. Oh, sometimes it's actually 0.00 something. Yeah. But okay, so is this 100% accurate? It does look like so, is it? I don't see any misplaced color of dots. That this one does look like 100%.
Yep.
Yep, yep, close enough. Yeah, yeah. So okay, very good. So there, and I guess the lesson is to deal with more complex data, you need to increase the so-called complexity of the neural network architecture. So by doing that, we either increase the input features, give it more information for the neural network to learn, increase the number of neurons in a layer, or a number of layers for the neural network. It seems to make sense, right? So for animal brain, remember, if you recall from your basic biology, there are simple brains or more complex brain. There are some simple brains, they'll have a smaller, a simple layers, like I think some of the amoeba or some a low-level animal. I forgot the a mollusk or something. They have a more simple brains, and then there are more layers. Worms, they have a simple brains because the worm can only do whatever feature you poke it, it actually shrink the whole body, right? Yeah. So yeah, that's the so by playing with this, I think some of the key lesson is increase the complexity of the neural network model in order to deal with more complex data or complex predictions. So, yeah. So you can actually imagine this is still just two-dimensional. If the data like more complex, like we how we talk, how we write, and then the neural network model will be much more sophisticated or more complex. So yeah. Uh, Questions about this type? Oh, which uh yeah. So okay, Aiden. By the way, where are you from, Aiden? Aiden.
Oh, I'm from Northern Virginia, right outside Washington, D.C.
Okay. Okay. Which high school are you going to?
I go to Bishop O'Connell. It's in Arlington, Virginia. It's a private school.
It's a private school. Okay. All right. Thanks for sharing.
Yep. You
Uh,
must keep sharing.
you can, yeah, you can start now. So actually, the next part is a bit more challenging. So I'm going to share, put my, I put, oh, sorry, I just, uh, put a private chat. I need to send to everyone. Okay, so I put a link, inside. So I'm going to share my screen. So actually, I wrote a few code which a bit more challenging.